Assalamualaikum and hi, my name is Karen Aisha Natasha binti Hasli with matrix number DE200058. Today I will present assignment 2, Fuzzy Logic Controller. So for the introduction, an intelligent control system frequently employs fuzzy logic control (FLC) to manage complicated and uncertain circumstances. So this FLC helps an intelligent control system to handle complex, ambiguous, or imprecise circumstances more effectively, and it can use human reasoning and experience to make judgments, analyze data, and react in a more logical and intelligent ways. So for this project, we are using 3 times 3 rules. If the two input have 3 fuzzy sets, the totals of rule would be 9. For example, in this table, we use negative, 0 and positive. Negative, 0 and positive, and the output will be in the table. Next, 5 times 5 rules. If two input have 5 fuzzy sets, the total of rules would be 25. And the rules is as in the table. We move on to task 1 and task 2.
Hello and Assalamualaikum. My name is Abang Kushafiq. So today I want to present and demo for task 1 for the fuzzy task. Okay, first I will put clear all. Then I will open the file that has been given, that is fuzzy PID. So I open it. Then it will pop up the fuzzy PID from this circuits. So this will be the fuzzy logic. So I will name FIS name is fuzzy post 2. Okay, I put okay. Then I will type a coding for fuzzy. Then it will show this type of fuzzy logic designer. Then I will put import some FIS file that I've been saved. So then it will come out this type of fuzzy logic designer. So first is error. So we can show NZP. So the range will be negative 100. So for the error rate NZP, the range will be negative 100 and 100. Then the voltage NI, ZI and PI. So the display range is negative 1, 4 and 1.4. Then I will show you the rules. So this is the input that we get, NZP, error rate is NZP, and voltage and NI, ZY, and ZI and PI. So it's have nine things that we show. This means 3 times 3. Okay, so I will close. Okay, then I will run the fuzzy PID. Then I will type plot TX blue, TX3 red. Then it will pop up this type of graph. So this is the graph that we get for 3 times 3. So this is the workspace 3 times 3. So that's all for me. Thank you.
So for the task 2, open the Simulink, and then this will pop out. Change time 3 to time 5, and then we back to the MATLAB. Type in fuzzy, and then this will pop out. Okay, for this task, we are using this range value which is negative 100 and 100. As you can see here, there is 5 graph, 1, 2, 3, 4, 5. Okay, for error rate, the range is negative 100 and 100, and voltage is the same value as error rate and error. So then we move on to rules. This is all 25 rules that we made because 5 times 5 is 25. Okay, and then we export the data to workspace, and we back to the block diagram. This is the data of the graph that we used earlier, as you can see here. This is all the try and error that I have made earlier. This is the latest one. Okay. After that, we run the code. After that, we plot the graph using this coding. After that, this graph will pop out. As you can see here, red is the output and green is the input. Compared to task 1, the output graph is below the input graph, so it is in positive error. So in this 5 times 5 graph, it is more accurate because it is closely near to the input graph. That's all from me. Thank you. So for the conclusion, FLC in MATLAB is a potent tool for resolving challenging and ill-defined issues in real-world systems, for example, in the field of biomedical and security systems. Through the use of mathematical and try-and-error concepts, systems can be controlled precisely and accurately. That's all from us. Thank you.